Here is a reaction of carboxylic acids. I think you might actually have seen this reaction or something similar in the first semester. Maybe this will ring a bell. We are going to take this material. This is a dicarboxylic acid. And we're going to take this material, which is a dialcohol or a diol. And then we're going to add some acid catalyst. And this reaction is a dehydration reaction. So first of all, can you name a reaction that involves a carboxylic acid, an alcohol, an acid catalyst, and loss of water? What kind of reaction is that? It's named after one of the great organic chemists, well, chemists really, of all time. This is a Fischer esterification. The product will contain ester groups in this particular case, because this looks like a system that maybe is set up to generate a polymeric product. So can you draw at least a part of that polymer? It may help to translate this type of writing into what this really is. So just above here, I'm going to redraw this structure. This COOH doesn't mean that these two oxygens, for instance, are bonded to each other. It's just a shorthand, or maybe a somewhat more convenient way of writing this. More convenient, perhaps, but less informative for sure. So this and this are the same thing. So what would the polymer look like? We're going to esterify using the alcohol. So if we put little labels in here, that label is still there. And here's the other oxygen. And then this second oxygen could also be part of an ester. So here is this part. And then that would continue on, etc. Over here on the other side of this, there's another carbonyl from the carboxyl group. And then the diol would be over here. And then this would continue, etc. over here. So this is a polymer. It's a polymer consisting of ester linkages. So say you were in charge of marketing for the polymer company. What might you call something that is a series of esters, one after the other, repeating over and over? A polyester. So this is a particular type of polyester. Depending on how the polymer is processed, one can make materials having different properties. So for instance, this is a polymer that is often used for drink bottles, like bottled water, for instance. It's called PET. If you look on your bottled water, you might see the little PET symbol. On the other hand, it can be spun into fibers, and one of the famous trade names associated with this type of polymer is Dacron. So you can use this as a fabric and make it into fabric-related products. So this is Fischer esterification using a dicarboxylic acid and a diol, which allows you to construct polymers of this polyester type.